Okay, let's move on. And now we will talk about access control. Postgres uses role-based access control system. So we'll talk about roles and privileges. Also, Postgres allows us to define fine-grained access control. So we'll talk about role security policies and about authentication. Roles and privileges. What is a role? You must think of role as a database user. In some databases, database user is not the same as operating system user, but there are some defaults that make it convenient to work with users with same names. For example, we use a student user in operating system, and when you type PSQL, you connect as student database user. Names are the same, but student in operating system and student in database are absolutely different concepts. Roles can have attributes which defines general possibilities or properties of role, not related to any particular database objects. For example, role must have login attribute to connect to a server. If you create a role with no login attribute, this role cannot log in to server. There are some other attributes, for example, super user. Postgres user is super user. We have create DB attribute, which allows us to create databases, create role attribute, which allows us to create other roles, and some other attributes, for example, replication. We will talk about replication in the next topic, and so on. So attributes define general possibilities of roles. And privileges defines rights of role to some particular database objects. For example, for tables we have 7 different privileges. To be able to query information from table, you must have select privilege. To insert rows, insert privilege. To update privilege. Also we have references privilege, which allows us to reference this table in foreign keys. Delete to delete rows, truncate to truncate table, and trigger to create triggers on that particular table. The 4 first privileges can be defined for some subset of columns of a table. For example, you can allow a role to select only some columns of a table. For views we have just 2 privileges, select and trigger. For sequences we have 3 privileges. They are not quite obvious, but let's work this way. More useful privilege is usage, which allows us to get current sequence value and next sequence value. Also, there are 2 other For database, we have connect privilege. Connect privilege allows us to connect to this particular database. We must have this privilege to be able to connect to this database. We have create privilege, which allows us to create schemas in this database. And for schema, we also have create privilege, which allows us to create objects in this schema. And also we have create privilege on table space level, which allows us to create objects in this table space. So to create an object, you must have create privilege for schema and for table space. Usage privilege for schema allows us to find objects in this schema. If you don't have usage privilege, you just cannot see objects in this schema. And also we have temporary privilege on database level, which allows us to use temporary objects, temporary tables and other temporary objects. And for functions, we have just one privilege, execute, which allows us to execute this particular function. But when we create our own functions, we can specify either security invoker, which is by default, or security definer. When function is defined, created with security invoker, it is executed with rights of the invoker role. And when function is created as security definer, it executes with rights of creator of this function. We will see it in demonstration. To give some rights to a role for some objects, we use grant command. Grant, then we specify privilege or several privileges on particular object to some role. And to revoke privileges, we use revoke command. Just replace grant with revoke and to with from. Okay. So you can create a role and grant it with some privileges to allow access to some objects. And role can be used as a group role. So it can contain other roles. You may say that some roles are membership of a group role. And these members of a group role have all privileges of group role. So you can grant necessary privileges to a group role and then grant this group role to other roles, and they all will have the same privileges as a group role. So it simplifies greatly managing of access control. You can create some role which cannot log in, for example, grant it all necessary roles, and then just give this role to any other roles for particular persons, for example. So a role in Postgres may be not only DBMS user, but also a group of users. In some versions 8 dot something, there were two different concepts, users and groups, but then they were combined into one role concept. Okay, we have three different categories of users. And this category defines how we apply access control rules. First category is super users, like Postgres. That is roles with super user attribute. For such roles, no access restrictions applied. So we simply not check any, not doing any security checks. So super user can have no privileges at all, but it can do anything it wants because we just don't check these privileges. The second category is owners. Owner is a role which creates the object. After you create some object, you became an owner of this object. Afterwards, you can redefine owner, but by default, it's a role which created this object. And also, members of your role also counts as object owners. Owners initially have all privileges for this object, all possible privileges, so they can do anything, everything, and also owners can perform actions which are not regulated by privileges. For example, we have no privilege for to drop an object. So you cannot grant drop to some role, it is impossible, and only owners can drop an object which they own. Also, owners can grant privileges to an object to other roles. And the third category is other roles, neither super users nor owners, and these roles access of these roles to objects is defined by privileges which is roles possess. There is one special role which is named public. It's kind of pseudo role because you cannot drop this role, but you can use it. Public role contains all other roles implicitly. So if you grant something to public, all other roles immediately have this privilege. This is defined in SQL standard, in fact. And by default, this public role has a lot of different privileges. It can connect to any database. It can access public schema and can create objects in public schema of any database. It has access to system catalog. It can execute any function in your database. And these privileges are granted automatically each time you create new object. For example, if you create new function, public role immediately has execute privilege on that function.
Execute any functions in the public or in every schema?
Every schema.
Don't impress them. It's going to get כל פעם הרשאות, לא?
Your public still must have usage privilege for schema.
User privilege.
Usage privilege for schema to be able to find this function. But if it has usage privilege, it can execute function in any schema. This is very broad spectrum of privileges. Sometimes it is convenient because you can work and just don't think about privileges at all. But in production systems, you probably want to revoke all these privileges from public and grant these privileges only to those roles which must have these privileges. But as I said, public will have privileges on any new objects which you create. For example, you can revoke execute on all functions from public, but when you create new function, public can execute it. But we have yet another mechanism of default privileges which allows us to automatically grant or revokes privileges when new object appears. We have alter default privilege command which we can use, and we will see in demonstration how we can use this command to automatically revoke execute privilege from public when we create some new functions. This is main security system, role-based access control system, and besides we have row security policies. Role-based access control allows us to restrict access to tables or to some columns, and row security policies works on rows, not on columns, not on tables, but on rows. This mechanism is disabled by default, and you have to enable it on each table that you want. And basically you define a predicate, a Boolean expression, which is evaluated for each row of your result set. And if this predicate returns true, you can see this row. And if the predicate returns false, you cannot see this row. This way we can restrict access to some rows for some roles. For example, we can store information from different departments of our company in one table and allow access for users of one department only to roles which belongs to this department. Or you can invent some other schema. In fact, we have two different predicates. One predicate for existing rows, which defines visibility of rows, and another predicate for new rows. When you insert new rows or updating rows, this predicate defines whether you can insert this new row into table or not. Starting from Postgres 10, we have starting from Postgres 10, we have permissive policies and restrictive policies. You can create several policies on the same table, and by default these are permissive policies. So at least one of your policies must allow access to the row, and then you can see this row. And you can define also restrictive policies. All restrictive policies must return true for the row to be visible. So permissive policies are united by OR logical operator and restrictive policies with AND operator. We will see a little example of this mechanism, but you not always need this. Generally, role-based access control is enough, and this is some additional method of restricting access. Well, and authentication. When a new client tries to connect to the server must decide whether it wants this client to connect. How it is organized? We have another configuration file which is named pgHBA. HBA stands for host-based authentication. This is text file. Each line defines some rule. We have several columns here, delimited by spaces or tabs. First column is connection type. Is a local or host. Local means Unix domain sockets, and host means connection via TCP/IP protocol. Then database, then user, and address. We have no address for local connections, but for host connections we always have address. So Postgres reads this file and tries to find first matching row, matching row record matching your connection parameters. For example, if we just type PSQL, we understand that this is a local connection. So connection local is okay. Database all means that this record matches any database. User Postgres, but we usually type PSQL under student Postgres in our virtual machine. So the user is not Postgres, and so this record is not matching our connection. Then we try to match the second row. Type is local, it's okay. Database all, user all, and so the second line is matching our connection parameters. And if we type PSQL -h localhost, then we use not Unix domain sockets but TCP/IP. And in this case, the second line didn't match, doesn't match our connection. And third, record matching, because type of our connection is host, any database, any user, and localhost is the same as this IP address. So the third line will work for us. If we cannot find matching row, we deny access, and client will get an error message.
What is the method?
Just a moment. What is a method? When we find a matching row, we look at the last column, this method, and use this method to authenticate our client. For example, for third line method is MD5. This means that Postgres asks user to provide its password. You type your password, and then Postgres checks whether this password is the same as stored in the database. I believe it's next slide. Yeah. So password MD5 is just authentication with password. Postgres 10 has another password authentication method, which is named scram. It is more secure than MD5 method. Besides, we have different other methods. For example, trust is always trust user. Don't ask him anything, just allow connection. Deny, reject, always deny connections. We can use reject, for example, to filter some IP addresses or something. We can put them on top of our file and use reject just to disallow connections from IP addresses, or we can disallow local connections or something else. Sometimes you can see peer method in this file. Peer means that Postgres asks operating system about current username, and if this name is the same as database username, it allows connection.
Can you use LDAP or something? LDAP is possible to use in Postgres?
LDAP, yes, it's possible. There are many other methods. You can use LDAP, you can use Kerberos, you can use client certificates, and so on. So it is possible. If authentication succeeded, then access connection is allowed. If not, then connection is denied, and no other lines are checked in this file. Why it is stored in file? Why it is not configured inside the database?
If somebody will edit this file.
Yes, you can always edit this file if you have access to operating system, but you can do some configuration that will not allow anyone to connect to database. For example, you just empty this file and no one can connect to the database to change these settings back. So file is more reliable. You always can edit it with text editor and allow connections. I think password authentication is used quite often. If you use password authentication, you must create roles with passwords. You can do it with password keyword. For example, create role, password, and you specify password you want. And you also can specify it valid until time for your role. Passwords are stored in pgAuthID table in system catalog. No one have access to this table except super users, so no one can see it, and usually it is encrypted anyway. When you use this authentication method, Postgres prompts you to enter your password. You can enter it manually, but sometimes you need to write some script which you want to execute automatically, and you want to provide the password from some file, for example. You can do it. There are two methods. First, you can set your password in pgPassword variable, or you can create .pgpass file in your home catalog, home directory. This file must contain lines in this format: host, port, database, role, and password. And all Postgres utilities will check this file, will try to find matching row and use password which is specified in the matching row. Well, let's see how it works. Okay, we will create two users here, one Alice and another user will be Bob. Alice will create some objects, some tables, and Bob will try to access Alice objects in the database. And on this example, we will see how this works. And let's start with creating a role. And for this role to be able to connect to the server, we must have corresponding lines in pgDay conf. We must have login attribute, and also we must have connect privilege to the database. First of all, let's look into pgDay file. Here I filter out comments from this file, so you can see only meaningful rows. This file is tweaked a bit for our purposes. Usually you will see peer instead of trust in this file. Here we use trust just for the sake of simplicity. We will connect to the server using TCP/IP protocol. So the third line will work for us. We can see here that everything is okay. We just need to provide password, so it's okay, and we don't need to edit this file. Now we create Alice role with some password, and we create a database. Here we specify login attribute, so Alice have login attribute, and we must check that Alice have connect privilege to this database. How we can check it? We can use has database privilege function. For example, here is the name of role, name of database, and name of privilege. And this function says that Alice has this privilege. Why it is so? We just created Alice and we didn't grant any privilege to it. Why is it so? Yes, it's default privileges of public user. Public can connect to any database, so Alice has the same privileges. How we can check it? We can use \l command to get information about our database. And here is access privilege column, which must show us current access privileges. Would you mind if I make font a bit smaller? That's okay. Like this. Here, this column is empty. It's not very convenient because we cannot see these privileges, but when Postgres shows you an empty field, it means that it have some default value in it, but it won't show you the value. It just says that it is some default, and you have to guess what is this default. But we can use this method. We can grant something to Alice and then revoke. Grant connect to Alice and then revoke. And this forces Postgres to show us what it means by this empty field. And here you can see some strange characters. What does it mean? The format is the following. On the left of the equal sign, we have grantee, so the role to which we grant something. To the right of equal sign, we have list of privileges abbreviated to single character, like this. And after slash sign, we have role name which grants this privilege to our role. For example, here we can see that student granted to student, to himself, these 3 privileges. And these letters mean C, capital C is for create, small c connect, and T temporary. So student, being the owner of this database, can has all privileges for this database. And when you see a line starting with equal sign, it means public role. You will not see public on the left from equal sign, but it is assumed. So public has temporary and connect privileges. That's why Alice also has these privileges. Okay, so it's okay. We can connect to our database as Alice. We can use this command. Here we use so-called connect string. We can write all parameters in one string. We can specify host, user, database, and password. All right. Yeah, in this topic, I have changed prompt. Prompt here contains name of role, names of current role. So if you see this line, it means that this command is executed on behalf of Alice. So Alice will try to create a schema which is named also Alice, and she gets this error message. What do you think happened here?
Doesn't have create schema.
Yeah. Permission denied for database, so Alice cannot create schemas. Alice is not owner of this database, and she hasn't privilege for creating schemas. So we can grant this privilege to her. Grant create on database to Alice. And after that, Alice can create schema. And as so she's the owner of this schema, she can create any objects in this schema It's no problem. Here is search path for Alice, and this search path contains Alice schema. As you remember, default value for search path is $user, comma public. $user replaced by name of current role. So this schema will be used by default for all objects which Alice will create. T1 table with 1 column and T2 table with 2 columns. First column is just numeric, and second column.
Excuse me. What
Yeah.
is the maximum size of text?
Maximum size of text. I think it's around 1 gigabyte
1 gigabyte?
or so
UTF.
in bytes.
Okay.
So in UTF you can get less characters in
But
the same
less, but
amount of
more.
bytes. I don't remember exactly, but I think it's like so. Text doesn't have, logically it doesn't have restriction on length, but of course it is limited physically. This second column gets default value of current user. So in this column we will have name of current role. Okay. Now we can create another user, Bob. And we connect to this database by Bob. We will use another session, which is indicated by vertical bars. Now Bob tries to access Alice table. Select star from alice.t1. What's the matter now? What happened? Why Bob cannot access this table?
Did he get any permissions?
No, he didn't.
Any permissions on
Only connect.
what?
Usage.
On the schema
Usage.
Alice.
On the schema, yeah.
He doesn't
So,
have permissions of
yeah, Bob cannot find an object because he has no permissions for the schema. Always read error messages. Here is all information. Permission denied for schema Alice. So we must grant usage on this schema to Bob. How can we check it? We can use dn command, describe namespace with plus sign, and it will show us access privileges. The format is the same, just another letters for privileges. U means usage. So Postgres no, we need this field for Alice schema. This field is empty. Empty is always means some default privileges. In this case, only owner has all access to this schema and no one else. So Bob doesn't have this privilege. And these are privileges for public schema, these two lines. And here you can see that public role has usage and create on public schema. This is default privileges of public role. Well, so Alice can grant create and usage to Bob, because Alice is owner of her own schema. Now Bob tries to access the table again, and he receives another error message. And here we can see that permission denied for table T1. So Bob has access to schema, but he don't have access to the table. Privileges for tables we can get by dp command, describe privileges. Also we can see an empty field, which means that only the owner of this table has full set of privileges. Now Alice can grant some privileges for Bob for her tables. For example, Alice grants select and update on T1 to Bob, and select for column N and insert on T2 to Bob. And after that, Bob can select and update first table, and he can insert rows in second table, and he can select only one column from the second table. Let's check it. Yeah, we can see how privileges changed. For table T1, we have this row for Alice and this row for Bob. Bob has read and write privileges. R and W means read and write, so it means select and update. And for the second table, Bob has A privilege, and A means insert. And column privileges are shown in another column of this table. Here we can see that for N column, Bob has read privilege, that is select privilege, which is granted by Alice.
Row privileges?
Hmm?
Row privileges? We speak previously about row security.
Drop?
Row.
Ah, row. No, it's not row security, it's column security. It's for column.
Where do you see the row privileges?
Including row privileges? Nowhere.
Okay. It's also an answer.
Yeah. Here we can see only role-based access privileges. Okay, so Bob can update T1, Bob can select anything from T1, but Bob say cannot delete rows from T1 because he wasn't granted this privilege. Also, Bob can insert rows into T2. He can select N column, but if Bob tries to select star from T2, he gets an error message. Okay, now let's talk about functions. For function we have just one privilege, execute. Let's create some function. This function will have no parameters, empty parentheses. This function returns a number of rows in table T2. And Bob can execute this function because public row can execute this function. Because this function, because public has this privilege. But by default, this function is created as a security invoker. So this function is executed with privileges of Bob when Bob tries to run it, and using Bob search path. Because Bob have no table T2 in his search path, he just gets an error message. So Bob cannot see Alice table through the function if he have no privileges for this table. But if Bob creates his own T2 table like this in public schema, then Bob will see a number of rows in his table, and Alice will see number of rows in her table. So this is kind of universal function. It can work with different tables with the same names. And also you can define your function as security definer. You just add this word, security definer, and when any role will execute this function, the function will be executed with Alice permissions and Alice search path.
Which means volatile.
Volatile means this function can return different values when it is called sometimes, several times inside the query.
Is there a plan compilation of functions in Postgres?
We have different volatility categories. A function may be volatile, maybe stable, maybe immutable. Immutable function always returns the same value for the same parameters, like no.
Every time the table beyond can be changed, of course.
Yes, yes. For
result.
example, mathematical functions are immutable because sinus, yes. Stable function always returns the same value inside one SQL query. For example, now will always return the same value, time stamp of your current transaction. And some functions can return different values. For example, random.
Okay.
Random always returns.
But return to the question about precompilation. Is there the concept of precompilation? For example, in SQL,
yeah.
Theoretically at least, every stored procedures is precompilation parsed. And in the first running, the execution plan is decided according to parameter sniffing. This is the method in SQL. Is the same thing or something like this in Postgres?
Postgres never compiles these functions. This is SQL function. It's not compiled. It's basically interpreted.
On the fly.
Yeah. But optimizer can choose different plans based on volatility.
If you speak about the optimizer,
yeah.
For a regular query, it's very easy to see the execution plan. You can say use explain command, but if there is a function, it's not so simple because you cannot see the behavior of the statements in the function. At least not directly. Maybe you can use auto-explain and so on, but is there a comfortable, simple way to get the execution plan of a function?
I think no, because sometimes Postgres can inline your function inline your function into main query, sometimes for simple functions. And if he cannot,
it's about complex function. It's more
yeah.
interesting with complex function, of course.
You have no such possibility. You can if you use explain, you will see function scan.
Function tomorrow,
Yeah.
yes, I know.
Yeah.
But
You can use
this is the reason for my question.
auto explain extension,
Yes, I use
and
it.
you can configure it to output plans of inner
file
queries.
to see the file.
Yeah. So let's continue. Now we can see that Bob and Alice they both see the same result because function executed with Alice permissions, and they get the same results here. So when you use security definer functions, you probably want to revoke execute privilege from public and grant this privilege to necessary roles only, because in this case any user can execute your function and maybe it's not what you want. Okay. Mm-hmm. So, no. I think 10 minutes maybe. Okay. As I said before, public role always have execute privilege on any new functions. Let's create, we can revoke execute on all functions in Alice schema from public, and after that Bob cannot execute this function, but if we create some new function, Bob can execute it because public gains this privilege automatically. So you can use this command, auto default privileges for all Alice, revoke execute on all functions from public. What does it mean? When Alice role creates any new function, execute privilege is revoked from public role on this function. DDP command will show you your default privileges, display default privileges. Here you can see this privilege in standard format. X means revoke execute. It's not like other letters, it's not grant, it's revoke execute. So we can drop our function and create it new. And you can see that Bob cannot execute this function because public was granted automatically this privilege, and then our default privilege revoked this privilege from public. So it's complicated, but it works this way. Now about role level security, about policies. Just a simple example. We have T2 table, and as you remember, we have a second column which holds username, name of role which created this role, and we want to show to roles only its own lines. For example, we want to show to Alice the first line and to Bob only second line. How we can accomplish this? We can create a policy, on some table using, and here we define our security predicate. It is very simple in our case. This column must be equal to current user. If this expression returns true, then the user can see the row. If false, then cannot see. After that, we must enable this policy for the table. Alter table, enable row level security command. And now Bob can see only one row from this table. For him it looks like this table contains only one row. He cannot know that there are some other lines. Bob can insert new rows, and he will see his own rows in this table. And for Alice, we can see all rows, because Alice is the owner of this table, and row level security by default not restricted owners to see all rows. But you can force it, force row level security, and after that Alice will see only her rows. This is very simple example. You can find more.
Alice can revert this action?
Yes, she's the owner of the table, so yes, she can. Also, you can have roles with bypass RLS attribute, and they also are not affected by row level policies. Okay, any questions about access control in Postgres? It's a bit complicated, I understand, but okay. So let's make a little break. We have practice, but I think we have no time for it.